Hi to all. Today we are going to discuss the topic called vector clocks in distributed system. This vector clock is very important. Here also we have to maintain the clock synchronization. As we discussed in the topic called Lamford algorithm, the C of A should be less than C of B. That means A tends to B. That means A should be smaller than the B value. The same concept here also the vector clocks was proposed to overcome the limitations of the Lamford algorithm. The Lamford algorithm, what are the limitations we have followed, that limitations are overcome by using the vector clocks. How means the properties of interfacing the A occurs before B is known as the causality property. A vector clock for the system n process in an array of n integers. Every process of Pi stores its own vector clock VCI. Every process is following its own vector clock, that is known as VCI. The Lamford time values for event are stored in VCI. So the Lamford timing is stored in a VCI. That VCI of A is assigned to the event. So that means here every event is having a own vector clock. If VCI of A less than VCI of B, then we can refer that A tends to B. That means a VCI of A should be less than VCI of B. Then we can say that if A tends to B. Okay. So here the vector clock is very important thing. How the vector clock is constructed by the following two properties. The VCI of I is the number of events that have occurred a process Pi so far. Then VCI of I is a logical clock of process Pi. If VCI of j is equal to k, then Pi is known as k event have occur P of I. Then VCI of j is P of I is a knowledge of logical clock at Pj. Here the increment VCI is whenever a new event is occur. Yes, definitely, because we have to maintain the VCI of A should less than the VCI of B. Whenever the new factor is occur, new event is occur, we have to increment the VCI values. That is very important thing. Then passing the VCJ along with the messages. Yes, because we have to send the information along with the messages only. Then here the vector clock updations. How the vector clock updation is happen? Because here we have a P3 process P0, P1, P2. If I want to communicate with the three process, the even time should be maintained. That means a P1 wants to forwarded, the P2 wants to backwarded. Suppose the P0 wants to forwarding means P1 wants to be a backwarding message. It should not overlapping the time of P1, okay, P0. Then only there should be a synchronization is happen. That's what they are mentioning here. In P0, I am having a VC0, VC01, VC02. That VC1 wants to be a minimum compared to that PC1 wants to be a higher compared to my VC0. How the interfering happened in event. How it means, suppose I am having a overlapping means I want to adding the timing. How we can adding the timing without overlapping means we have to mention, we have to look after upwarding event. If the upwarding event is a less than a forwarding event mean we have to add the values together in a upwarding event. Then we can avoid this mismatching or avoiding, we can maintaining the synchronization because of clock cycles. And enforcing causality communication. Assume that the message is multicast within a group of process P0, P1, P2. Enforcing causality order, multicasting the delivering a message from Pi to Pj can delay until the following two conditions are met. That two conditions wants to be satisfied. First condition is a time wants to maintain in particular process that should be equal to VCI of I plus 1. That means the time should be VCI plus 1 it wants to maintain. And also that time of k is less than or equal to Vj of k plus all the thing. Okay, that wants to be added. Assume that the Pi is only increment when VCI of I update the send the message to adjust the values of P0. Then P0 here, if suppose, see this diagram. In this particular diagram, the P0 send the message same way to P1 as well as to P2. That should be a clock synchronization. The first thing is not a issue. So there is no there is no overlapping, so there is no issues. The second thing is P1 send the message to P0 as well as P2, but what happened here, this P1 send the message to P0 P2, right? Thus there is a overlapping. That means a P1 sent the message before that P0, so there is a overlapping. So that message wants to be forwarded before the P1 P0 messages. Here that blue arrow mark is here, right? So that message is forwarded, so there is a overlapping. That overlapping is avoiding by resending the messages. A logical clock is embedded with a employed whenever the process has to be agree and related order on the event, but not necessary actual time of event. Two types of logical clock is maintained. One is a Lamford logical clock, another one is a vector logical clocks. So we have discussed enough about the vector logical clocks in previous slides. So Lamford clocks is also we have discussed enough. The thing is that we have to maintain the clock event timing. That is a very important thing. Thank you to all.